here for the same circuit, we try to solve it using another method called the mesh analysis. So for the mesh analysis, we will all the way use KVL, Kirchhoff voltage law, to write out the formula. Okay, so here how it works is like we also define this is the ground node, and for the mesh analysis we need to define some mesh. So for here we have two loops here, so we can actually define this is mesh 1, and let's say this is mesh 2, this is I2. Okay, so here you can see this is I2, and then this is I1. Okay, so we just ignore this I1 first. Okay, so yeah, so I3 we can see I1 going here, I2 going here. So this I3 will be I1 plus I2. Okay, so the idea is like this. So let's try to write out the mesh equation for mesh 1. Okay, mesh 1, which is this mesh. So let's say we try to start from this point. Okay, so here, starting from here, we can consider this is the beginning point, and then going in this direction. Okay, so let's consider this is high, this is low, and then we define this direction is positive. So here we have so this is high, this is low, and then we consider this is I1 times R1, and then going through this E1. Okay, this is also high, this is low, so we also consider this is E1. This is a positive E1. Okay, and then for this mesh, okay, we go from point B to point D. Okay, so the current going through R3. Okay, so R3 should be multiplied by this mesh and also this mesh, and then with the same direction. So we should have I1 plus I2 here, and then equals 0. Okay, so this is the equation for mesh 1. Okay, because we have a two mesh I1, I2, 2. Okay, so this is the current mesh. Actually, the current mesh. Okay, so this is the first mesh equation, and then for the second one, let's say we start from here. Also, this is high, this is low, so we have a I2, R2, also a plus sign. And then here, from this point C to point B, okay, this is also high, this is also low, so we have a plus E2, and then plus also this one, it will be I1 plus I2 times R3 equals 0. Okay, so actually we have I1, I2 to be unknown variable, and then we have two equations, so that you may be able to solve I1 and I2 based on these two equations. Or maybe I just put it here, mesh 1 to be I1 R1 plus E1 plus I1 plus I1 plus I2 R3 equals 0. And then for mesh 2 will be I2 R2 plus E2 plus I1 plus I2 R3 equals 0. Okay, so actually we can simply collect the similar terms. So this is I1, this is also I1, so we have a R1 plus R3 times I1, and then plus R3 times I2 equals negative E1. Okay, and then for this one we have I1 and then R3. Okay, and then plus this is I2, So here we have a R2 plus R3 I2 equals negative E2. Okay, so this is joint equation with two variables. Okay, so you may be able to solve it using your high school mathematics knowledge. Okay, so you may be able to have I1 and I2. We can have I1 and I2. So after knowing I1 and I2, we may be able to know all the potential difference. Let's say across this one will be I1 times R1 will be the potential difference, VDA, and then for example VBD will be R3 times I1 plus I2, like this. Okay, so you can see, actually for the node analysis and mesh analysis, for most of the circuit, it will have a similar complexity. Let's say it will have among the same number of almost the same number of unknown variable and equation you need to write. But for some specific case, let's say this one, we only need to write one node analysis because VA, VB, and VC are all dependent voltage. So we only need to define VB, and then we can have a VA to be VB plus E1 quickly. So these two are dependent on each other. These two are dependent on each other, which means that all these three node voltage are all depending on each other. So we need to define one variable, and it means that we only need one equation to solve this unknown variable. And for this same circuit, if we try to define the mesh, actually we have two loops here, so we have two current mesh. So in this case, or mesh current. Okay, so in this case, we need to write two equations to really solve I1 and I2. Okay， 但是我是告诉你们，电路理论里面有这个东西了。但是其实如果你要简单的话，你永远都用这个就好了。这个就对于初学者的话是相对比较容易理解，或者是比较简单，不容易犯错的。就建议你用这个就好。那这个的话就是相对比较抽象一些，就是有一些这个怎么转，为什么这个又顺时钟，这个又逆时钟？当然你也可以全部都定义顺时钟的。那如果你定义这个是 I2 是那样的话，那这个电流就会变成是 I1 减去 I2。如果是这个 mesh 的时候，那如果在这个 mesh 的时候，就会变成是 I2 减 I1， 就是这个就是有一些很多正负号。其实解电阻式电路最麻烦的话，就是很多正负号。那些量的话，你都知道嘛 ，V 等于 IR 嘛。那 potential difference， EMF 的话就是那个 E 嘛，没有什么特别。最难的话就是正负号。Okay, so next is the parallel resistance. Okay, so actually we have introduced it before, so I don't try to repeat it. So the parallel resistance is taking the reciprocal of the individual resistance, add them together, and then take the reciprocal again to be the equivalent parallel resistance. So nothing special here. Okay, so here is a summary table about the series parallel resistance and capacitors. So actually this is chapter 27. Okay, so it does not introduce the inductor yet. Okay, so you can see here resistor and capacitor. So for series capacitor, we add all the resistance together. For series capacitor, we take the reciprocal, add them together, and then take the reciprocal again for the series capacitor. For the parallel resistance, we take the reciprocal and then add them together, and then take the reciprocal again for the equivalent parallel resistance. But for the parallel capacitance, we have a CEQ to be the sum of all the individual capacitance for the parallel capacitance. And for the inductor, okay, if we have a series inductor, L EQ will be summation of L J equals 1 to small n. Okay, series similar to the resistance. Okay, parallel. Parallel. Okay, we have a 1 over L EQ equals summation of 1 over L J from 1 to small n. Okay, so inductor are similar to the resistor when we try to calculate series or parallel resistance or inductance. Okay, the capacitors are different. And later in chapter 31, you may have some idea why it is reverse. Okay, 如果要剧透的话，就是说那个电阻的 the impedance of resistor is actually R, and then the impedance of L is J omega L. Here J is square root of -1. 然后 Z of C, okay, impedance of capacitor is 1 over J omega C. This is the J. Okay, so here you can see for the impedance of capacitor, it has a reciprocal here. So actually we take the reciprocal again, and then they will be somehow like the same thing. Okay, and then in the next chapter, you know why it will be like that. It is actually related to this is V equals L dIdt. We introduced in chapter 30, and this one is related to I equals C dV dt. I think I did not introduce this one, but actually Q equals ZV for capacitor. So if you just take derivative on both sides, you have a dQ dt equals C dV dt. Okay, because C is a constant. Okay, so we don't need the product rule. We only have a C times dV dt. So actually this one is the current. Okay, so the current of a capacitor is the capacitance times the dV dt. Okay. Yeah, maybe I have introduced a bit. Okay, so here we have another sample problem. Okay, it says figure A shows a multi-loop circuit containing one ideal battery, and 4 resistance R1, R2, R3, R4 with these values. Okay, what is the current through the battery? Okay, so So here, okay, this circuit is not totally series or not totally parallel, but actually you can consider these R2 and R3 are parallel. Okay, although this is vertical, this is horizontal, but actually, if you just look at this part, okay, you can simply feel that, okay, these two no connect together, also actually R2 and R3 are parallel with each other. So here we have R2 parallel with R3, so which is 20 times 30 over 20 plus 30. So this is nothing but 12 ohm. Okay. Although originally parallel resistance should be taking the reciprocal and then add them together and then take the reciprocal again. But if you have only 2 resistance parallel with each other, it is like the product of them divided by the sum of them. Okay, so so this is this, and finally the total R equivalent will be R1 plus R2 parallel R3 plus R4. Okay, so substituting this as a parallel resistance, so it is 1, 2, 3 in series. Okay, R1 plus R2 parallel R3 plus R4. Okay, so this is nothing but R1 is 20 plus 12 plus this 8. Okay, so this is 40 ohm. So finally, the R equivalent is something like we have E, and then this is R equivalent. So this is I, this is I, this is also I. So the current go through the battery should be E over R equivalent, which is E is 12 volt over 40. Okay, so this is 0.38. Okay, so this is pretty simple. Okay, so for part B, what is the current I2? I think it means the current going through the R2, going through the I2. Okay, so here we have a VBC. VBC is actually this is I. So VBC will be I times R2 parallel R3, okay, which is 0.3 what we calculate in part A, and then multiplied by 12 ohm. So this is 3.6 volt. Okay, so here we know VBC, the potential difference between point B and point C, VB minus VC. Okay, so here we can actually calculate I2 by Ohm's law. So I2 is actually VBC over R2. So this is 3.6 over R2 is 20 ohm. So this is 0.18A. Okay, so what is the current I3 go through R3? Okay, so this is I3. Okay, so actually you can consider this is you can also make use of I3 equals VBC over R3, which is 3.6 over R3 is 30. So this is 0.128. Okay, so also you can use right hand rule. Sorry, not right hand rule. Not Ohm's law. Ohm's law. Okay, and or you can also use KCL. KCL at this point. I3 will be I minus I2. So it is actually 0.3 minus 0.18, which is 0.128. Okay, which give you the same answer. Or actually, we can use something called current divider. Current divider 就是把电流分开的一个东西。Okay, current divider is a bit more advanced, but yeah, the idea is like I3 will be I times something. Yeah, because we have a total I here, and then these two are parallel resistance, and then which means that the sum of I2 and I3 should be I. So here we will say that I is divided into two parts. One part is I2, one part is I3. So I3 is I times a ratio less than 1. So this ratio will be R2 plus R3, and then with R2, R2, yeah, in the numerator. Okay, so if you use this 0.3 and then times R2 is 20, and then 20 plus 30. Okay, so I3 will be 0.128. Okay, the idea here is like if the resistance is larger, then the current will be smaller. If the resistance is smaller, the current will be larger. So in such a way, we put another resistance here. If there are two resistors in parallel. Okay. Similar, you can also have I2 equals I times R3 over R2 plus R3. It will also give you 0.18. Okay. So which means that the solving circuit can be very simple. You can find many different ways to find the same answer. Okay, not only single solution. Okay, so far any questions? 可以问啊，就是因为我们是做电路的，所以就觉得非常简单，所以会不自觉的讲得很快。所以如果你们不熟悉的话，就是不妨提出来，因为有些我觉得太简单的就没有强调，有时候只是可能你不知道的。OK。OK， 没有的话我们继续吧。那 OK, so this is another sample problem. So 27.4. Okay, so it says the figure shows a circuit with the elements have following values: E1, E2, R1, R2. The three battery are ideal battery. Okay, so here we have a three battery: E1, E2, and E2 again. Okay, so find the magnitude and the direction of the current in each of the three branches. So which means that we need to find I1, I3, I2. Okay, so actually we can make use of mesh analysis here, okay, to let you slightly familiar with the mesh analysis. But of course, you can still use node analysis. Using node analysis is okay. So let me point out how to use node analysis a bit, but I don't try to use node analysis here. So actually we can just try to assume this is a ground node. Okay, so this will be E2, this will be E2, this will be A, and then this will be E1, this will be this is A, and this will be, okay, so this will be another voltage. Okay, let's say this will be, let's say this is VC, this is VC. Okay, so VC, this is VC plus E2. So in such a way we have VA, VB to be independent values. So in this case we need two equations to resolve VA and VC. Yeah, so if you have interest, you can try to practice yourself by yourself and then to see whether it gives you the same solution. Okay, but here we try to use mesh analysis to do this. So for the mesh one here, okay, starting from, let's say starting from this point, okay. Okay, so here is going up, low, high. Okay, so here we have a positive E1 equals low, high, and then this is high, low. Okay, so it is equal to I1, R1, and then for this one I3 is this. Yeah, actually the mesh is going in this direction. Okay, so going through this R2 will be, this is positive, this is also, I2 is also positive. So in such a way we have a I1 plus I2 times R2. And then this is high, this is low. Okay, so here we have a plus R plus E2. Okay, something like this. And actually we still have this one. For this one, this is plus I1 R1. Okay, and then going back to this original point. Okay, we actually start from here. Okay, this is E1 on the left side, and then going down is this point, this is I1 R1 here, and then I1 plus I2 times R2 here, and then E2 here, and then I1 R1 here. And then for mesh 2, let's say we start from this point, or maybe you can quickly see that we have a E1, E2. Okay, this is going from low to high and then high to low. So Okay, so maybe you can see it's something like this. So this is or maybe we can just let me see how to make it easy to answer. So let's see. Here we have let's say this is the loop. Okay, this is high, this is low. Okay, so let me try to put it on the right side. So this is I2 R1, and this is low, this is high. Okay, I try to put it on the left side. So this is E2, and then this is so this is for this one low high and then high low. So this is I2 R1 plus I2 R1, and then going to this part. Okay, this is positive. So we have a I1 plus I2 times R2. And then for this one, high low, I still put it on the right side, E2, and then going back to here, nothing else. Okay, so something like this. Okay, so here we can try to simplify these two equations. So for the first one, we have a E1 minus E2, equals, we can call that I1, and I1. So we altogether have 2R1 plus R2 times I1 plus I2 is here, this is I2, okay, nothing else, R2, I2, okay. And then for the second one, we can simply cancel E2 on both sides, and then we have I1 here, so we have R2 I1 plus this is I2 and I2. So here we have a 2R1 plus R2 I2 equals 0. Okay, so this is two equation, and then we can just plug in all the numbers. 3 minus 6 equals okay, this is 2 times R1 plus R2. Okay, 2 times 2 is 4, plus 4 is 8 I1, and then plus R2 is 4 I2. Okay, and then we have a 0 equals 4 I1, and then plus 8 I2. Okay, so this is two equations with two unknowns. Okay, so we can simply know that I1 equals negative 0.58, and then I2 equals 0.25A, something like this. So which means that actually I1 is counterclockwise with the magnitude to be 0.58, and I2 like this. I2 is also counterclockwise. So I3, the I3 should be I1 plus I2. So which is negative 0.5 plus 0.25, which is negative 0.25A. Okay. So which means that I3 is actually going up. So if you have interest, you can try to practice the node analysis at home. Okay, so for the node analysis, okay, try to define VA and VC, and then write two equations. Okay, and then you will be able to solve VA and VC, and then to see whether it matches this this solution. Okay, actually you can try to find VA quickly because this is E2. E2 is 6 volt, and then I3 is going up 0.25. So it is like this is high, this is low. So this is 4 minus I3, which is 0.25 times R2 times 4. Okay, 4 times 0.25 is 1. Okay, so this is like 6 minus 1. This is 5 volt. This is 5 volt. And then VC is very easy. Very easy. So this is nothing but I2 times R1. I2 times R1. I2 is 0.25. Or I should say this is a negative. This is a direction. Okay, so this is negative R1 times I2. I2 is 0.25 and then R1 is 2. So this is negative 0.5 volt. Negative 0.5 volt. Okay, something like this. Give me 1T.那我大学的时候啊，他还说有一些更快的方式，就直接可以写出这一行，直接可以写出这一行。他说的方式就是说，我这个圈它上面有 R1、R2，所以就加起来就直接写这里，就是这样，就是这样。然后这一个跟 I2 会有重叠的地方，所以 R2 就直接在这里了，R2 就直接在这里了。那类似的，这个 loop 这个 I1 跟 I2 有重叠的 ，R2 就直接放这里，然后这一个圈 R1、R2，所以就直接放这里，然后你就稍微看一下这个圈，定一下这个E1、E2 的方向就直接可以写出来，还不用写这个。但是这个是比较难一点，就是太快的话，通常就是比较容易犯错。Okay, so here we talk about the ammeter and voltmeter. Okay, so ammeter. So here it says an instrument used to measure current is called an ammeter. So to measure the current in a wire, you usually have to break or cut the wire and insert the ammeter so that the current to be measured pass through the meter. OK， 所以他说要断开它，就是意思是原来电路长什么样？原来电路的话是长，这里有一个 battery， 这里有一个 R， 这里有一个 R1， 这里有一个 R2， 这样的，这个是1原来的电路长这样。你想要测一下这个电路的电流。那你就要把这个电路断开。You need to break the circuit, and then you insert the ammeter in series with the path, with the current path you want to know. Okay, so here you try to break it here, and then insert the current meter, the ammeter here, so that you can measure the current going through the loop. And then if you try, a voltmeter later on. So so it also mentioned that break or cut the wire and then insert the ammeter. Okay, so it also mentioned that it is essential that the resistance RA. So actually this is a device. It should have some internal resistance. You can consider it's RA. Resistance RA. So it says this RA should be very, very small. Should be very, very small. Much smaller than the internal resistance of the total resistance of a circuit. Okay, so it's essential that resistance RA of the ammeter be very much smaller than the other resistance in the circuit. Otherwise, the very presence of the meter will change the current to be measured. 因为它的意思是，因为我们多了一个电阻 RA 在这里。那刚才说的就是原来的电流是1除以 R1 加 R2 加小 r， 那现在的电流就变成 R1 加 R2 加 R 再加 RA， 所以这个 RA 一定要很小，不然的话，整个电路的电流都改变。OK。So the next, the meter used to measure potential difference is called voltmeter， 就是测量那个 potential difference 或者测voltage difference. To find the potential difference between any 2 points in the circuit, the voltmeter terminals are connected between those points without breaking or cutting the wire. 所以这个 voltmeter 是跟它并联的是跟它并联的你想要测 VCD 的话，那你的 voltmeter 就直接接在 VC 跟 VD 这两个点，你就可以测到这个 VCD 的 potential difference。然后one point to mention is that it is essential that without breaking or cutting the wire. So it is essential that the resistance RV of a voltmeter to be very much larger. This is smaller. This is much larger than the resistance of any circuit element across the voltmeter is connected. Okay, so here, this is actually RV. Okay, so here RV should be much larger than R1. Otherwise, there will be large current going through. Okay, if this RV is very large, then the current going through RV will be small, because as I mentioned, the current divider is like if the whole current is I, and the current going through the voltmeter IV should be R1 plus RV, and then this is a current meter, so it depends on R1. It depends on R1. Okay, so if RV is very large, then this current will be small. Okay, and then making it ignorable. Otherwise, if RV is not large enough, this current can be quite large. It can be a certain portion of the total current, and it will actually influence the original current I. Yeah, because it is like if RV is small, then R1 parallel RV will be somehow smaller than R1. Okay, and then it will influence the current. Yeah, because this parallel resistance becomes smaller. Okay, so this resistance also becomes smaller. It makes this I become larger. Okay, so here we have a RC circuit. Okay, so let me try to maybe we need to take some time. So maybe we